So we'll get started, everyone. Welcome back. I hope you'll have a wonderful holiday. So we've got to have a quick chat about what our plan is for the term. So I'll bring that up on the second up here so we can have a bit of a look and see what's going on. So we're in term 3 and we've got one test left. This is our last unit on statistics, so you will need your stats notes book. If you haven't got it, there'll be a time you can go grab it a bit later. I'm going to project the notes today just so everyone can see. Okay, so today our plan will go over 8A and 8B1. Both of these are very short exercises. And you'll find that I actually teach what we need for 8A and 8B1 and 8B2. So you can launch into B2 if you want, although we've got tomorrow's lesson dedicated to that as well. Now this unit, what you'll find is each lesson, we probably won't need all of the time dedicated to the textbook work. There'll be some exercises that are very short, sort of 4 questions, which means you can spend some time on your folio. It's up to you how you're going to use your time, really. I would like to see you do textbook work, but I understand people want to spend time on their folio as well. Today I'm going to come see how you've been doing. I've got a checkpoint that I want everyone to at least upload a document with hopefully some stuff that they've done. So I don't care how rubbish it is, but it's just a sort of satisfactory, non-satisfactory, have you been doing a little bit of work? Okay, so everyone will be uploading that to Sector today. So that's happening today. Then Friday, week 3, that's when your draft for the folio task is due. And then Friday, week 5, that's when the final for the folio task is due. I'm happy to negotiate those dates. If you find you finished your draft and you want to get it in early, that's fine. I'll get it done sooner as well. So that's our plan. And then if you're looking along at Sector, this unit, we'll finish the unit at the end of week 5 there, or week 6, at the end of week 5, and then we've got the test scheduled for early week 7. So that's going to be when our last test is. That gives us a lot of time to go over in class together some exam revision. You get about probably 2 months of exam revision in preparation for the exam to make sure we're nice and prepared. Okay, so yeah, it's all wrapping up pretty quick. Any questions about the plan there at this stage as far as dates and so forth goes? Fantastic. Okay, so let's get into our notes then for 8A and 8B. And we'll open up here, we've got this exercise 8A, a continuous random variable. Okay, so remember we've made a distinction between discrete variables, or we have random variables that we did in exercise 7A. We make the distinction between discrete, these are things that you count, and continuous, these are things that you measure. Okay, so weight and height and time and so forth. So we have 50 eggs are weighed at random, and their weights are shown in the frequency table below. So between 50 and 55 grams, we had 6 eggs. Okay, and then the relative frequency, well, we've got 6 eggs divided by 50 eggs in total, 0.12. Based on our data, 12% of the eggs are between 50 and 55 grams. And so on for the rest of the data. Okay, so we've got between 55 and 60 grams, we had 13 eggs. Now, just in terms of notation there, okay, we've got less than or equal to. So if I have 50 less than or equal to x less than 55. Okay, what that means is from 50.0 onwards. Okay, 50.00000 onwards. Okay, so we're including 50, but we're not quite getting to 55. So what it means is 54.9999999 would be included, but as soon as you get to 55, it's in the next boundary. So we're familiar with that sort of notation. 50 eggs in total, all probabilities add to 1. We can present this data as is it a histogram or a column graph? Arguably, like for your purposes, they're probably the same thing. The technical difference is that a histogram, this one here, is used for continuous data. And you'll notice how the columns are squished together, whereas a column graph is for discrete data and they have spaces between the columns. That's the technical difference. All right. Okay, so here we're confronted with this. Based on the data, Let's read that sentence first as well, because this is important. The probability of a continuous random variable being equal to an exact value is always zero. Always zero. For instance, if we've got the eggs here then, the probability that an egg weighs exactly 62.9 grams is zero. And you might say, well, that doesn't seem right. How can one egg not weigh exactly 62.9? It's because with continuous variables, there are always finer and finer gradations. And so sure, you might find an egg that weighs 62.9 grams, but if you measure it further and further and further to get a more accurate representation of it, you might find it's 0, 0, 0, but then there's a 1 here. If you measure it far enough, you'll always have a non-zero number there somewhere. Okay? So for continuous random variables, you can never have an exact outcome. Continuous variables are always over an interval. So that's one way we can really identify discrete variables. Discrete variables have exact outcomes. That's what we did in chapter 7 with binomial distributions, all right? How many, okay? We're counting discrete variables. Whereas for continuous variables, we're talking about a range, okay? Find the probability that the weight of a randomly selected egg is between 55 and 65 grams. It exists somewhere over this interval. Okay, so let's look at our data. If we're going between 55 and 65, we're going to add both of these together. 0.26 plus 0.4 gives us 0.66. Based on the data, the probability of an egg weighing between 55 and 65 grams is 0.66. Okay, so that's exercise 8A. Do not spend long dwelling on exercise 8A. It is some easy maths in there. You know, cast your eye over it, make sure you understand it, but we won't spend long on it. Okay, let's move on to 8B1 and 8B2 then. And in here we're talking about what we call a probability density function. Okay, so a probability density function. So for some continuous variable x over the domain a to b, the probability density function is the area under the curve. All right. We'll scroll down. We've got a couple of examples of these. Two takeaways from here are these dot points at the bottom. For it to be a valid probability density function, two properties it has to satisfy. The first one has to be above the x-axis. Okay? You can't have a negative probability. We know that from chapter 7. And then the second one is that all probabilities must add up to 1. The area under the curve over that interval has to be 1. Okay, and that follows on from chapter 7 as well. We also have, this will be more addressed in 8B.2, but we'll go over it now because it all just goes together. But these are statistical properties of a probability density function. Let's get straight into our example. Consider the function x on a, which is valid over the interval from 0 to 4. Okay, so the probability density function is x on top of a. All right, now I think the best way to think about this kind of function, whenever we have something written at the bottom, is pull it out the front, isn't it? It's 1 on a times x. And what type of function is this? It's the equation of a line, okay? Y equals mx plus c. There's no plus c, there's no y-intercept, and so it's going to look something like this, all right? And we're told that it's valid from 0, x is 0, to x is 4. Okay, that's what it's starting to look like, this probability density function. Okay, now, part A says, find this value of a given that it's valid. Well, given it's valid, all right, the area under the curve from 0 to 4 has to be 1. The integral from 0 to 4, from a to b, okay, the domain of our probability density function, of our probability density function, must equal 1. Okay, all probable events, the probability under the curve has to be 1. If we're going to determine if it's valid, it has to satisfy two properties. Firstly, it has to be above the x-axis, and the second one, area under the curve, has to be 1. We're told it's valid, which means it's above the x-axis, and now we're going to solve here for a. That's what we're trying to solve for. I'm going to pull the 1 on a out front. and evaluate the integral at the same time. The integral of x is x squared on top of 2. Alright, so what did I do? I pulled 1 on a out front. The integral of x is x squared on 2. We've got our definite boundary there. I'm going to now multiply both sides by a as well. I'm trying to solve for a, so if I multiply both sides by a, what we'll have here is this definite integral, x squared on 2 from 0 to 4, and we'll have a. And we can evaluate that now using the fundamental theorem of calculus. We'll sub in 4, and that's going to be, what, 16 on 2, we get a is 8. This component is 0. So we've determined the value of a. Okay, which means the probability density function then is x on top of 8, or 1 on 8 times x. You can think about it. Either of those is fine. That's what the probability density function is. It's valid for 2 reasons. The area under the curve over its domain is 1, and it's positive. We can't have negative probability. Remember those, keep those in mind. Okay, part B says find the mean, the median, and the mode. All right, so we're going to look at the box above to answer all of these. These are going to pop up more in 8b2 rather than 8b.1. But we'll just start with the mean. Okay, the mean is the integral over its domain of x times the probability density function. So this is going to be from 0 to 4 of x times, what's the probability density function? X on top of 8 with regards to x. Now, the only time you're required to do it manually is if it says using an algebraic process, using fundamental theorem of calculus, etc. So we should get in the habit of, for specifically statistical calculations, just cranking them in your calculator. So we've got x squared on 16, that's what that's going to simplify to, from 0 to 4. The mean is 4 on top of 3. Okay, that's our mean. Alright, next we will do the median. Now, the median is the middle value. Okay, so what that means, like if this is our area under the curve, it means the median is some line here such that this is half the area. Half of the area is 1, so half of 1 is half. This is half the area and this is half the area. This is our median. So we need to determine the median such that, here's the statement we make for it. The integral from the lower boundary to n of our function is equal to half. Okay, now that we can solve algebraically, or you can put it into equation solver. You can type this notation into equation solver. I might go through that now, I think, how to use the calculator to evaluate those kind of integrals. So if you can pull your calculator out, and we go down to equation, and we go to solver, delete whatever's there, and we just type in this statement. Okay, the only difference is instead of n, we're going to put x there. So option calc integral and the way you bring up the equals is it's the shift dot right at the bottom, the full stop button. And I've solved this. I've got 2.82.
Is it square root of a?
Very good. 2.83. Did you do it manually?
Is it square root of a?
It is. Well, you just know that.
No.
Did it manually. Nice work. Okay, so we type that in. I'll float around. Does anyone have any issues typing that in and evaluating that? Yep. make sure we know how to use this, because you'll use this in your folio task as well. Excellent. Oh, you just need to press solve. Yep, so just go up to it. Yep, there we go. Is there an X? I'll just put X, because that's what we're trying to solve.
Equations.
Yep, Lama, do you get it? Yep, that's correct, just press it. Yep.
It says equation, so it's orange.
Just press it, evaluate. Still that's good?
Oh, then just press solver. Press F3.
Got it, mate? So up here, just make, go up there, we'll make that equal. What's that? So just I want to solve this equation. Joel, what do you
You have to find the n that splits it. So put n as one of the oh, the mean. The mean was you just put in.
Okay, alright.
Oh, you just put in an extra x.
But did you get the same answer?
It's just an equation. It just says the mean is this.
I reckon you just didn't evaluate it, that's all.
The mean is that. Yeah, the mean is that.
Okay, good. So,
It's on you.
so we've evaluated that. Now, we got 2.82. The other way a question might want you to use integration is if it says find it exactly. Okay, so we know here we've rounded it to 3 significant figures. That's not an exact value. If we're required to find something exactly, that means performing the algebraic technique. Okay, so we've got the mean, we've got the median. All right, and hopefully we're okay with evaluating, solving that manually. All right, that's a technique that's popped up in both chapter 4 and 5. Let's look at the mode then. And the mode, if we read it, the mode is just the event with the highest probability. Okay, so what we've got here on this graph is we have the probability on the y-axis, and we can see from the graph that probability is highest here, which is 4. Okay, so our mode is 4. We've got our mean, median, mode. Okay, variance and standard deviation for part C. We're just given 2 equations to evaluate those. I'm just going to evaluate the variance, and then I know the standard deviation is the square root of the variance. Okay, so for the variance, we've got a couple of formulas we can use, doesn't matter which one. Let's do the second one. So we've got the integral from 0 to 4 of x take the mean squared. We saw the mean is 4 on 3. X take the mean squared and then multiplied by the probability function x on 8 with regard to x. So we're just going to type that in to evaluate the variance. I'll do the standard deviation in the moment. Has anyone done it yet? Option cow integral. And you don't need to simplify it. You can just type that hog mess in and it'll sort it out for you. 4 on 3 squared multiplied by x on 8 from 0 to 4. Got 8 on 3. So then the standard deviation is the square root of 8 on 3. Okay, so we've done part A, B, C. We're up to part D now. So basically from this question, part A and part D will pop up in exercise 8B1. Part D says, find the probability of 1 being less than or equal to x being less than or equal to 2. So this is a probability density function, and it's saying, what's the probability of the event being between the number 1 and the number 2? What's the probability of this event? It's just the area under the curve between 1 and 2. So we're going to do the integral from 1 to 2 of our probability density function with regards to x, and we'll just evaluate that using our calculator. From 1 to 2, not from 0. 3 on 16. Okay, now notice this is a probability, it's less than 1. Probabilities should be between 0 and 1, they should not be negative. Okay, so that's a suitable answer for us. The other way we can evaluate that is, of course, graphing the function. Okay, and graphing the function will often be useful because it allows you to g-solve the maximum values, all right, when you hit the highest point, and you can just calculate area under the curve straight off the function if you've graphed it as well. All right, so what I've provided for you now is enough to get into 8A and all of 8B. So that means tomorrow I won't really need to teach anything. So it's up to you where you're going to dedicate your efforts, whether you want to roll through all the textbook work now and then do some of your folio tomorrow, or whether you want to do a bit of your folio now and the textbook work at home. It's really up to you. I'll float around, catch up everyone, see how you're all going. But yeah, that's our plan today and tomorrow. Yeah, did anyone else need help with the calculator?